was diverse and consistent typography generation. Our research objective is typography generation task that aims at producing diverse typographic styling for the given graphic document. We formulate typography generation as a fine-grained attribute generation for multiple text elements, and build a model to generate diverse typography that matches the input design context. Our context and typographic attributes contain multiple modalities. We summarize the data in the table. Our context attributes consist of the canvas input and the element input. In this work, we consider the following typographic attributes as outputs: font color, font size, alignment, capitalization, angle, letter spacing, and line spacing for each text element. Our typographic attributes have semantic and geometric quantities. We show illustration of the typographic attributes in the figure. We extract features and discretize continuous attributes based on the k-means clustering. We build an encoder-decoder architecture based on transformer to effectively capture the interaction among the inputs and the target attributes within the attention mechanism. Our architecture combines path-style transformer blocks with skip connections between the input and output to each element. We adapt an autoregressive decoder to model the joint distribution of typographic attributes. While autoregressive sampling can adjust sampling hyperparameter for each attribute, we find the plain autoregressive approach sometimes corrupts the consistency and distinction among element styling. Here we propose the structure-preserved sampling, which is a simple two-step inference approach that effectively controls the diversity while preserving the typography structure. The intention is that top-one sampling gives the best typographic structure, and the second sampling generates diverse examples, while forcing the consistent structure from the initial inference. Our approach is heuristic but generates visually plausible typography without significant overhead. We evaluate the generation task using the clear dataset, which includes various design templates in vector format, since the original dataset doesn't contain all of the necessary typographic information for visualization. We collect additional resources like TTF files. We parsed and compiled the typographic details of each template and finally obtained 23,495 templates that contain text elements in the vector format. We split the clear dataset to train test value with the following numbers. We show generation examples by our model. Our model have only a few elements but have sufficient contrast and consistently generates diverse yet plausible typography even when a document has many text elements. This figure shows qualitative results for comparisons with existing techniques. Canvas VAE tends to ignore the input context. We suspect Canvas VAE suffers from learning a good single latent space for complex tasks like typography generation. Besides, Canvas VAE cannot independently control the diversity of different attributes, which causes poor overall appearance. Our models generate sufficiently diverse typography for individual attributes in each element, and with structure-preserved sampling, the results hold consistent styling across elements. We plot the attribute metrics and the structure score of font as we increase diversity hyperparameter. We observe that our models show a good quality diversity trade-off compared to Canvas VAE, while a plain top-D approach clearly degrades the structure score as we increase diversity. Our structure-preserved sampling keeps constant score in the highly diverse regime. Note that our structure-preserved sampling can slightly drop the attribute metrics compared to the plain autoregressive sampling due to the cases when the initial structure prediction fails. We show some failure cases of our approach. Our model doesn't explicitly handle the appearance of typography and sometimes generates unintentional spatial overlaps between text colors that are difficult to see, and overflow over text elements due to the unawareness of the final text width. Further, if our model fails to capture the plausible structure, generated results corrupt.